All right, calculus, back to your quiz review number 2. Here's number 17. I made a boo-boo on my, I think I printed this out for you. I'm going to say probably that you have these answers. Well, anyway, 17's wrong. Anyway, here's what we do. We got use substitution, use that denominator. Okay, it means du is negative 5 dx. So dx, which is the only thing there in the numerator, is going to be a negative 1/5 du. So that's what we got. Okay, that means we have u to the negative second. Okay, du, negative 1/5 on the outside. 1 power up divided by the new power. Negative times the negative is a positive. 1 over 5u. Now remember, what is u? I haven't changed the bound, so I got to plug 3 minus 5x back in. That would give me a 15 minus 25x. 15 minus 25x. That's a 15. All right, I'm going to plug 2 in. That'd be 1 over negative 35 minus, plug 1 in, 1 over negative 10. That's negative 2 over 70 plus 7 over 75 over 70, which is a 14th. All right, my answer was negative 5. First off, I was just wrong on a few accounts there on number 17. Here's what you can also do. Maybe you wanted to change the bounds. You're going to learn that in videos 4 and 5 for this section. All right, so we got the same thing, okay, but if I want to keep this solely in terms of u, if I plug the original upper bound of 2 in for x, I get negative 7. If I plug the lower bound of 1 in for x, I get negative 2. But notice how negative 2 is bigger than negative 7. So when I plugged in 2, it was my lower bound, but now it becomes my upper bound. When I plug in, when I plug in 2, it was my upper bound, now it becomes my lower bound. When I plug in my lower bound, it now becomes my upper bound. So what would happen is I would switch the bounds, but I'd have to multiply by a negative 1. Again, if the upper bound becomes the lower bound and the lower bound becomes the upper bound, you just multiply the integral by a negative 1. So that's what happened here. All right, so now I get a negative 1 over 5u. I plug in negative 2 as my upper bound, negative 7 as my lower bound, which I did, and I still get 1/14. However you want to do that one, we'll talk more about doing that later. 1/14, though, is the actual answer for 17. All right, back to 18. Another way to write that is 3 over x, which is 3 times 1 over x, which is 3 natural log x. Plug in e to the third, plug in 2. That is what we got. All right. On 19, hopefully I didn't make a mistake. You're going to let u be that. That means du is 2 dx. I only need to plug something in for dx. So 1/2 du equals dx. That means I have u to the 1/2. I'm not changing the bound, so I got to plug, when I take the antiderivative, I got to plug 2x plus 1 back in for x. I did not change the bounds. I plug 4 in for x, and when I do so, I get 8 plus 1, that's 9. And then I plug 0 in, I get 1. And what is that? 52 over 3. Right, again, you have these answers. I'm just going to do a quick explanation. This is a massive quiz review. We have literally done 20. Just take the antiderivative. It's so any secant x tan x, the antiderivative is secant whatever that x is. Now the derivative of 2 theta would be 2, so the antiderivative is going to give you 1/2 on the outside. Just do the 20. On 21, we've done something very similar in the notes. U is going to be sine theta, so du is simply right there. That's u, that's du. So I'm going to have u to the 8th. So that's going to be 1 power up divided by the new power plus c. Plug in u. No bounds there. All right. 22, possibly u substitution time. All right. So if you let u be that, then du, believe it or not, again, you should know how to do this. Bring down the power, 1 power less. Du would be 1 over 2 root x dx. I only want 1 over root x dx, so I multiply both sides by 2. That would be 1/2 of du, so I got to put a 2 on the outside, so it'd be 2 e to the u du. And I derivative that is still 2 e to the u. Plug in root x for u, and plug in 9, plug in 1. All right, that one is not too bad. Number 23, use substitution. U is natural log x. Du would be exactly that. So this is pretty nice. You have u squared du. 1/3 u to the third plus c, no bounds. Plug natural log x in for u. 24. U is going to be that right there. That is going to be u. So du is 3x squared dx. I need to plug something in for x squared dx. So that would be 1/3 du. 1/3 du is that. That is u. And I'm raising it to the 1/2 power. 1 power up divided by the new power. That's what we got. All right. We've done something similar. And I tell you what, I took this antiderivative so many times in one of my classes. So u is going to be negative x squared. Du would be negative 2x dx. I need x dx, so I'm going to divide by negative 1/2. All right, so this is negative 1/2 du. That is u. I'm all good. Negative 1/2 is on the outside, e to the u du. Antiderivative is e to the u. Negative 1/2 there. What is u? Again, this is something you can probably check just taking the antiderivative. E to the x, those ones aren't too difficult there. Oh, we got some bounds. All right, so if you let u be x, then du would just be dx. You'd still have to deal with that. So if you let u be natural log x, then du is 1/x dx. 1/x dx. And then this would just be u to the 1/2 in the denominator, which is the same thing as saying u to the negative 1/2. 1 power up divided by the new power. Plug in, again, that's the square root. Plug in natural log x. Man, that's, so first off, this would still be 5, but you're taking the square root of 5. That would still be 1. You're taking the square root of 1. 1 times 2 is 2. Interesting answer. All right. Raising that to the 4th, that's got to be u. If u is cosine x, then du is negative sine x dx. So sine x dx, which I need to substitute something in for, again, that's u, is going to be a negative du. This right. It's my daughter downstairs crying. She is her mama's responsibility right now, so we're just going to disregard that. This is a negative u to the 4th du. 1 power up divided by the new power. What is u? It is cosine. All right, so negative 1/5 cosine of pi to the 5th minus a negative 1/5 cosine of 0 to the 5th. And here it is. And I don't believe you see an answer. This should be 1/5 plus 1/5, right? 2/5. Looking good. All right. 28. This is how I would write it. E to the x over e to the x plus 1 over e to the x. There you go. Derivative of our antiderivative of 1 is just x. What's the well, the derivative of this would be e to the negative x. When you take the derivative of that, it'd be multiplying by negative 1. Here you would divide by negative 1. Doesn't matter. It's still going to be negative e to the negative x plus c. All right. We're going to let u be that because it's being raised to the 4th. So du would be 3x squared dx. But you need to substitute something in for 6x squared. So what'd you do? You double this, which means you have to double that. This right here would be 2 du. That is u. 2 u to the 4th du. 1 power up divided by the new power plus c. Plug in x to the 3rd plus 2 in for u. All right. Done a lot of these. Hopefully you're getting the hang of them relatively. And finally, the last page. Again, we'll be doing this quiz in some way. I need to figure out how the rest of the semester is going to go. So I'll hope and pray I get to see you again on April 14th, but this quiz is going to happen. Somehow, u is sine theta, so du is cosine theta d theta. Again, that's du, check. That's u, which is being raised to the 3rd. This is all good. Again, if I wanted to, I could change the bounds. If u is sine theta, then my upper bound would be 1. My lower bound would be root 2 over 2, and that does go in order. Root 2 over 2 is less than 1, so I could have done that. I didn't, so I have u to the third 1 power up, divided by the new power. Then I'm going to plug in pi over 2 in for theta. Then I'm going to plug pi fourths in for theta. Quarters on the outside. Anyway, that's how it simplifies. All right, on this one here, e to the x over this. If I let u be 3 minus e to the x, it's a gosh darn circus in this house right now. Du would be negative e to the x dx. E to the x dx, that's a negative du. All right, so negative 1 over u squared du. Then... Hey, sweetie, I'm trying to make video. And we're back. All right. So, e to the x dx would be a negative du. Put a negative on the outside. 1 over, again, I could have plugged in and made this simply in terms of u. I could have plugged that 1 in there, that 0 in there. But I didn't.